That wraps up today's briefing. The signal for today is simulation. We are moving from simulating intelligence to simulating people. With the rise of synthetic consumers that can predict purchase behavior with 90% accuracy, companies can now A/B test products on thousands of AI agents before manufacturing a single unit. The feedback loop between idea and market just got infinitely faster and a lot cheaper. Before we go, a reminder for the leaders listening: are you drowning in dense legal text? JamgaMind is the new audio intelligence platform that turns 100-page healthcare or energy mandates into 5-minute executive briefings. Whether you are navigating Bill C-27, Canada, or the CMS 0057F interoperability rule, USA, our AI agents decode the liability so you don't have to. Start your specialized audio briefing today at jamgamind.com. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Please subscribe and share. Until Monday, keep unraveling the future.
Welcome back to the Deep Dive. Today is January 16th, 2026, and the signal from the AI world. Well, it's deafening. It's telling us that the rules of engagement they've fundamentally changed. We're seeing some major tectonic shifts in where power truly lies. And it's all being driven by, unprecedented spending and really strategic positioning. So if you're an executive charting a platform strategy, or maybe a developer choosing which architecture to optimize for, or even an investor just trying to spot the next trillion-dollar market, this is absolutely essential context.
That's exactly right. I mean, you can forget the incremental feature updates we sometimes talk about.
This is not small tweaks.
No, not at all. Our stack of sources today details 4 massive, really coordinated moves that redefine the entire competitive landscape. And our mission here is to extract those nuggets of insight, the high signal information, and give you the deep context on what all this actually means for your strategy.
And these 4 core shifts they're dramatic. First, we have Google. And they're establishing what looks like a true personal intelligence moat. They're using contextual data that money, it just can't buy. Second, something we're calling the chip revolt. And it's being headlined by OpenAI's staggering, very high-stakes $10 billion bet on Cerebras. It's signaling the end of single-source hardware dependency.
And then third, we're going to dissect the collapse of traditional market research. The synthetic consumer era has, I think we can say, definitively arrived. The implications there are instant, radical, and global. And then finally, we'll look at the legal closing of the data-free ride. We're seeing the absolute necessity of strong IP and likeness protection in the age of generative AI, where, every piece of data is becoming a compensated commodity.
4 huge topics, and each one threatens to disrupt a multi-billion-dollar industry, or, in the case of hardware, redistribute tens of billions in supply chain spending. Okay, so let's unpack this. Let's start with the one advantage Google holds, the one that rivals like OpenAI can only dream of acquiring: proprietary personal data context.
It's really the foundational currency of advanced AI, isn't it? I mean, beyond raw compute, it's deeply contextualized data. And in the race to build a truly useful, proactive AI, well, Google has just unveiled its trump card.
This personal intelligence beta feature, it's for Gemini AI Pro and Ultra subscribers in the US. And it is not a minor update. This is the realization of a strategy that's been decades in the making. We've seen attempts at personalized AI before, sure, but this is about deep, unified reasoning across a user's entire digital life, not just, fragmented access to individual apps.
Right. It's the move from an assistant that just answers your questions to an agent that proactively reasons across your entire digital history. What Google has done is enable Gemini to reason across a user's proprietary application suite. We're talking Gmail, photos, your YouTube viewing history, aggregated search data, all of it, simultaneously and crucially, automatically.
And that key is unified reasoning. That's the phrase. We're not talking about chaining prompts where I have to say, search my email for the receipt, and then, okay, now look in my photos for the item I bought.
No, the user doesn't have to do that work.
Right. The AI is tasked with solving a problem, and it's supposed to pull the necessary context from text, from images, from video, all without the user having to specify which app to even look in.
And that requires a really sophisticated multimodal fusion architecture. And it has to be running continuously in the background. I mean, think about the complexity there. The AI has to distinguish between structured data, like the date in an email, and then unstructured, contextual data, like the metadata on an image or what you said in a YouTube comment 5 years ago. And it has to do this in real time to generate one cohesive response.
And the anecdote from VP Josh Woodward really brought this home. He talked about being at a tire shop, a situation where you typically need to access several pieces of scattered information very quickly. Your vehicle specs, previous maintenance records, maybe a photo of the current tire tread.
Right. Things that are all in different places.
Exactly. And the AI uses context from his photos and his emails to proactively provide all the necessary information right there in the moment. It transforms the AI from a search tool into this seamless, proactive utility layer.
And that right there is the core difference.
Mm-hmm.
It's the difference between where Google is headed and where almost everyone else is currently operating. Competitors have largely raced to achieve parity on general reasoning tasks. You know, if you ask Gemini, ChatGPT, or Claude about global economics, the answers are going to be mostly indistinguishable.
They're all pretty good.
They're all very good. But when the AI can tap into your individual life history, your travel receipts, your purchasing patterns, the faces and places in your photo library, it transcends general capability. It becomes indispensable utility.
Okay, and this is where it gets really interesting and why this establishes Google's moat. The sheer scale of it and the existing infrastructure are just unmatchable. Billions of users already have their lives, their entire context, graphs stored, structured, and active within the Google ecosystem. OpenAI can try to partner and integrate, but they have to convince you to sync your life piece by piece, app by app, into a third-party environment. Google just needs you to tick one box within the environment you already inhabit and, for the most part, trust.
It's the ultimate network effect applied to data, but with this added layer of stickiness. As frontier models equalize in capability, and they are, very rapidly, deep integration with personal context becomes the ultimate differentiator. This is the new deep moat.
But that moat is built right on the edge of public trust, which is, as we know, highly fragile. Google is demanding unprecedented access to our personal data, and that introduces a huge liability risk. They must be addressing this head-on with some critical guardrails. But how convincing are they?
They seem to recognize the gravity of the trade-off. To maximize the utility while, attempting to minimize the trust violation, they've implemented two key controls. First, the feature is explicitly off by default.
Okay, that's critical.
It is. It means the user has to make an active, informed choice to opt in, recognizing the enormous value exchange they are making.
And the second point, I imagine, has to address that existential fear we all have, that our personal data is going to become part of the global training set.
Exactly. And Google explicitly states that it will not train its AI models directly on connected information like your inboxes or your photo libraries accessed through this feature. This promise is crucial. They're trying to assure you, the user, that the data is used for you, the individual, but not by Google, the corporation, to improve the underlying model. That promise is the very thin line separating utility from violation in the public's mind.
But if I'm an executive or a strategist listening right now, I have to ask, how do we verify that promise? I mean, in a black box AI system, verification is basically impossible. This places the strategic reliance entirely on Google's corporate trustworthiness and their internal monitoring.
Absolutely.
The value of this deep, personalized context is enormous for creating sticky, proactive products. But the liability of a breach, or even just the perception of misuse, is exponentially higher.
And it forces every competitor to think about their own personal graph strategy. If you don't own the data, you have to partner aggressively, or you have to start building that trust right now. And this trust issue is exactly why Google's sheer platform depth continues to be such a barrier.
And we saw a really interesting counterpoint today, actually, with OpenAI's launch of ChatGPT Translate. They're trying to chip away at Google's dominance in a core utility area. But the limitations of their launch immediately highlight Google's existing platform and infrastructure advantage.
Yeah, ChatGPT Translate certainly offers some clever AI-powered prompt options. You can, reshape a translation to sound formal or simple for a child or academic. And that's a nice cutting-edge feature. It demonstrates their model's sophistication. But when you look at the foundational utility layer, the gap is vast.
It really is. The fundamental infrastructure features that Google Translate mastered years ago, they're just missing from the ChatGPT offering. We're talking comprehensive document uploads, full website translation capabilities, real-time conversation interpretation, and, critically, broad language support. Google backs over 50 more languages.
And this just reinforces the idea that while OpenAI can compete effectively on the creative application layer, True platform depth, the infrastructure you need to run comprehensive, low-latency, globally available utility, is still a massive multi-decade barrier to entry. Google's advantage isn't just data, it's the robust, battle-tested systems they've built over 20 years that support the scale of these personalized offerings.
So what does this all mean for developers? I mean, this personal intelligence sets an impossibly high new benchmark. If your model doesn't understand the user's life context, it's going to feel archaic next to Gemini Ultra. You have to develop integration strategies now.
And for investors and strategic leaders, the race for contextual data is now the main event. It forces every competitor, Meta, Apple, and certainly OpenAI, to either aggressively develop their own personal context graph through deeper OS or social integrations, or they have to find strategic partners with massive, trusted data ecosystems. Context is the new API.
Okay, so we just saw how data and platform depth create a moat. But that personalized utility is, well, it's worthless without the hardware to process it quickly and at scale. And that brings us to the compute layer, because the pressure on the supply chain and latency is leading to a $10 billion investment in Revolt.
The premise here is pretty simple. For 2 years now, AI capability has been shackled by the Nvidia bottleneck. The availability of specialized compute, primarily high-end GPUs, has basically determined who gets to train the next frontier model.
Right. It's been a kingmaker.
It has. And the news today shows that the biggest players are taking radical steps to diversify away from this single point of failure. And this push for hardware independence is happening simultaneously on 2 critical geopolitical fronts.
Let's start in the West, because the number is it's astonishing. OpenAI's $10 billion multi-year deal with Cerebras. This is not a small R&D project. This is a declaration of war on the status quo.
It is a decisive and very high-stakes move. OpenAI has signed a contract worth over $10 billion with Cerebras. That's the AI chipmaker famous for its wafer-scale engine technology chips built across an entire silicon wafer, not just a small square die.
Right, the giant chip.
The giant chip. And this massive contract commits Cerebras to providing a stunning 750 megawatts of dedicated compute power through 2028.
750 megawatts. I mean, to put that in perspective for people, that's equivalent to the electricity consumption of a city the size of Omaha, Nebraska, purely dedicated to running OpenAI's workloads. So what's the why behind this colossal investment, and why specifically target a challenger architecture like Cerebras instead of just, trying to secure more standard Nvidia supply?
The strategic goal is twofold, and it speaks directly to the constraints they're facing. First, they need massive, dedicated scale away from the primary bottleneck. They're diversifying their supply chain risk. Second, and maybe more importantly for their customers, the purpose is achieving faster outputs through a dedicated low-latency inference solution.
Okay, let's focus on that low-latency inference, because that's the customer experience layer. Inference is the process of using the trained model to generate responses. And latency, the time it takes, that's the killer of perceived AI performance, especially for complex multi-step queries.
Exactly. And Cerebras' unique architecture is specifically suited to tackling this latency problem. See, a standard GPU cluster requires data to be broken up and communicated constantly between different chips across a high-speed network, like InfiniBand. That inter-chip communication introduces bottlenecks and latency. The Cerebras wafer-scale engine is essentially one gigantic processor with massive on-chip memory. It keeps the entire model and its computations localized on a single giant piece of silicon.
So by minimizing that external communication, they minimize the wait time. OpenAI is validating Cerebras' core claim with a $10 billion check. They're saying that specialized wafer-scale chips are inherently faster and more efficient for specific high-demand inference workloads than general-purpose GPU systems.
It's a fundamental strategic move to secure scale and diversify risk. However, let's introduce a note of skepticism here for our investors. This $10 billion contract is crucial validation, yes, but Cerebras is a company that has delayed its 2024 IPO, while reportedly seeking to raise another $1 billion at a very high $22 billion valuation.
That sounds like a significant operational risk. I mean, betting such a massive sum on a company that hasn't proven its financial stability on the public markets yet, isn't this also a sign of just desperation for compute access?
I think it shows that the need for supply diversification outweighs the financial risk associated with the partner. The cost of not securing compute scale is far higher than the risk of Cerebras' valuation wobble. This investment signals that access to compute capacity, especially capacity optimized for low latency inference, is the single most valuable asset for a model provider today.
Okay, so that's the West's move to secure specialized scale and lower latency. Now let's turn to the East, because China's response to the chip war is not reactive. It's about proactively building parallel self-sufficient infrastructure.
Precisely. We're seeing hardware independence being driven by geopolitical necessity and U.S. export controls. The Chinese startup Zhipu AI, which has already impressed globally with its large language model, GLM 4.7, just made a powerful statement. They released GLM-Image, a new 16 billion parameter open source image generator.
And the crucial detail here, the thing that makes this a geopolitical signal is what?
This model was trained entirely on Huawei's Ascend chips and software stack. With zero reliance on U.S. semiconductors or architecture, this is the first major, capable, open model trained fully within a self-sufficient domestic Chinese hardware stack. It's not just a technological release, it's a proof of concept for national resilience.
That's a monumental achievement, just in terms of establishing a parallel supply chain, even if the performance isn't market-leading yet. And speaking of performance, Zhipu is claiming some impressive metrics, particularly for niche use cases.
They are. They're claiming GLM-Image excels particularly at text-heavy images, which is something image generators often struggle with. And they say it beats a competitor like Nano Banana Pro on specific internal accuracy benchmarks. However, early user reality suggests that while it's highly capable, it still trails the very top closed options like Nano Banana Pro and Dream on overall photorealistic quality and creative coherence.
But if we connect this to the bigger picture, that performance gap, while it's relevant for consumer metrics, it isn't the primary strategic driver here. The main story is the geopolitical signal. Zhipu's aggressive moves, releasing this domestic hardware-trained model right after their powerful GLM 4.7 and their recent Hong Kong IPO, it proves that China's AI industry is not waiting for export controls to relax. They are building a self-contained AI ecosystem from the silicon up, ensuring their national security and technological future are not dependent on external vendors.
And the implication for developers is clear. The market is fracturing. Hardware is becoming specialized, not standardized. You can no longer rely on optimizing solely for Nvidia's stack.
Right.
To address the massive Chinese market or specialized enterprise needs globally, you will increasingly need to optimize models for different architectures. We're talking standard GPUs, Cerebras wafer-scale engines, and Huawei's Ascend stack. This complexity introduces significant friction.
And for investors.
The era of the single hardware king is, I think, indeed approaching its end. Compute supply chain fracturing creates both risk and opportunity. The risk is high operational friction and potential lock-in. The opportunity is in investing in the enabling software layers, the compilers, the optimization tools, the middleware that make cross-architecture deployment and performance tuning easier. The money is flowing to alternative chip producers and the software that ties them all together.
Let's move now from the foundational layer of hardware and data to a completely different industry facing what looks like immediate terminal disruption: market research.
This is a story about efficiency and accuracy finally meeting breakthrough technology. For decades, companies have spent billions annually on consumer research. It's the engine that justifies product development, pricing, and marketing spend. But we all know the inherent flaws of traditional methods.
It's a slow, messy process. I mean, traditional surveys suffer from biases like social desirability, people lying about their habits or preferences to look good, and they rely on faulty human recall. You need hundreds or thousands of real participants, and the whole process takes weeks or months just to establish statistical significance.
And by then, the data is stale.
The resulting data is often stale before it's even actionable. Exactly.
And that's why the research finding we have today is a seismic event. It proves definitively that large language models, when you prompt them correctly, can accurately simulate human consumer behavior and, most critically, purchase intent, or PI, with approximately 90% accuracy.
90% accuracy. That's a level of reliability that matches or even exceeds the reliability of human test-retest panels. This is total disruption. But the research goes with a crucial, immediate warning about the methodology.
Yes, the flaw to avoid. And this is the first thing any startup trying to apply this needs to know. Simply asking an AI to rate this product 1 to 5 produces garbage data. The models, when they're forced into a simplistic quantitative scoring mechanism, they lose the context and reasoning that makes them predictive.
So the breakthrough isn't in the scoring. It's in the simulation of human thought and qualitative expression. Which leads us to the innovation they call the semantic similarity rating, SSR. This is the aha moment for our listener. The precise, validated methodology that actually works. So lay out the 3 steps for us.
The breakthrough relies on leveraging the LLM's capability as a cognitive simulator and then using a separate consistent mechanism to quantify the output. Step 1 is the role-play prompt. This is the setup. You explicitly prompt the LLM to adopt a granular, specific demographic and psychographic profile.
Give us an example of how granular this gets.
Okay, it could be something like, you are a 35-year-old female, a mother of 2, household income $75,000, residing in the Midwest, interested in high-end, sustainable skincare products, but you're price-sensitive toward items over $100. This locks the model into a defined cognitive and financial framework. It makes its responses predictable and segmentable in a statistically meaningful way.
So it gives the AI an identity and a constraint. Okay, what happens in step 2, the impression generation?
You show the AI the product concept, the image, the description, the competitive positioning, the pricing. You then ask the AI to write a natural, qualitative impression or review. The output is long-form text, not a score. For our example, the output might be something like, I appreciate the transparency about the natural ingredients and the sustainable packaging, which aligns with my values, but given my budget, the $150 price point feels significantly too high for a monthly purchase.
That is precisely the kind of rich, conflicting, qualitative reasoning a real human provides. It integrates value judgment, budget constraint, and preference.
Exactly. And then comes the quantitative link that turns this qualitative insight into actionable data. Step 3, mapping. A separate, pre-trained system maps this natural qualitative text to a numerical score using embedding similarity. The language model isn't grading itself. The system is grading the meaning of the language.
Okay.
So if the text contains language strongly similar to known descriptors of high intent like must buy, perfect fit, affordable value, its score is high. If the text uses language similar to negative intent like too high, major drawback, will wait for a sale, it scores low.
And the research confirmed that 0 training data is needed for this mapping process because the LLM is already a superb simulator of human language patterns across demographics. That 0 training data point is financially massive. It means you can deploy this methodology today using existing frontier models without months of specialized data preparation.
But the real question is, how solid are these results? This kind of claim requires extreme rigor.
Let's look at the validation data because this is where the skeptical investor or developer is won over. Researchers tested this method on 57 real consumer surveys that had already been executed by a major corporation. And they compared the synthetic results against 9,300 actual human responses used as the ground truth.
The results were conclusive. They showed 90% of human retest reliability. That means the synthetic consumers were behaving with the same consistency as real human consumers tested weeks apart. Furthermore, the statistical distribution match was validated using something called KS similarity, which was greater than 0.85.
Hold on, that statistic, KS similarity greater than 0.85, sounds like pure math jargon. For the strategist listening, what does that number mean in plain English in terms of real-world confidence?
In plain English, it means the synthetic population's distribution of opinions, the spread of high, medium, and low purchase intent, perfectly mirrors the distribution found in the real human population. It's not just that the average scores matched. It's that the model successfully recreated the entire population's nuance. It proves the AI understands and reproduces how different demographic segments think about products, not just what they might say on a simple multiple-choice quiz. This is predictive power.
This is a fundamental paradigm shift. I mean, this doesn't just improve market research, it functionally destroys traditional market research economics. The massive implications are felt across speed, foresight, and granular targeting.
The speed advantage is paralyzing to traditional firms. You can now A/B test 1,000 different product concepts, color schemes, pricing structures, or names overnight, instead of spending weeks recruiting, scheduling, and processing thousands of manual surveys.
And that speed translates into unprecedented foresight. You can simulate market reactions before you commit to a major manufacturing run. I mean, imagine instantly testing whether raising the price point by 15% would alienate your high-income demographic while attracting a new, value-seeking segment. You have predictive pricing elasticity data within hours.
And the targeting capability is revolutionized. You can instantly test dozens of different messaging campaigns across 50 demographic segments simultaneously to see not only which message resonates, but which specific segment has the highest purchase intent for that message. This is hyper-granular targeting at machine speed, and it completely changes the economics of digital marketing optimization.
So concept to market cycles just got 10 times faster. The prediction that real market research panels might be obsolete within 2 years? That's not hyperbole. This synthetic consumer era validates the idea that LLMs are powerful cognitive simulators moving far beyond mere text completion.
And it raises huge questions for consultancies and marketing agencies. Their primary value proposition access to reliable, structured consumer insight is now potentially democratized, accelerated, and rendered vastly cheaper by this breakthrough methodology. They must pivot their services from data collection to strategic data application.
And that pivots us perfectly from simulated intent to very real intellectual property rights, because the gold rush era fueled by free data is definitively coming to an end.
The legal and ethical battleground has been raging for a while now, but today's news signals a turning point. A point where the value of human likeness and proprietary data is finally being recognized and, crucially, compensated or legally protected. The premise that developers can simply scrape the public internet for free training data is now obsolete, and it's being driven by both legal action and market necessity.
Let's start with the protection of human likeness, highlighted by Case 1. Matthew McConaughey securing his assets against AI misuse. The actor is using the trademark system in a very deliberate and aggressive way.
He's treating his identity as a federally protected commercial asset, and that's the key distinction. McConaughey successfully secured 8 trademark approvals from the U.S. Patent and Trademark Office. They cover his voice, his likeness, and specific video clips, including the audio signature of his famous catchphrase, "All right, all right, all right."
So why this proactive trademarking strategy? Celebrities have always had some legal recourse through state-level publicity laws. Why is federal trademark protection superior leverage here?
This is the strategic brilliance of the move. Relying on state-by-state publicity laws is slow, it's complex, it's inconsistent, and often weak in commercial contexts, especially when you're dealing with entities operating internationally or across state lines.
Right.
Federal trademark law, however, provides a direct federal court avenue to pursue AI misuse. It's a clean, strong legal hammer that is superior for dealing with infringement at the scale necessary for large language models and generative AI platforms.
So in essence, he's creating an immediate clean perimeter around his digital identity. He's making his consent mandatory for commercial use. Otherwise, it's just straightforward infringement.
Exactly. His stated motivation is very clear. He's combating AI deepfakes and misuse by ensuring that ownership with consent and attribution becomes the norm in an AI world. And this move serves as a direct blueprint for every major public figure, from athletes to musicians, who has significant commercial value tied to their voice, image, or catchphrases.
And we can tie this directly back to the urgency of the problem. The recent drama surrounding X and Grok's generative capabilities showed exactly why this protection is so necessary. Users exploited Grok to create non-consensual explicit images of real people, and it forced immediate and chaotic restrictions on the platform.
Oh, the regulatory and public scrutiny was intense. X was immediately forced to restrict image creation and editing through Grok to only paid subscribers. They also added geo-blocking in regions where generating images of real people in minimal clothing is illegal. The fact that the platform needed this kind of immediate, drastic intervention illustrates the urgent necessity for robust perimeter protection like McConaughey's.
Okay.
This is an enterprise risk issue. If a major platform struggles to control what its model generates, the liability immediately falls on the platform.
Okay, that addresses the protection of likeness. Now let's turn to Case 2, the monetization of proprietary data, featuring the Wikimedia Foundation. This signals the definitive market acceptance that high-quality structured data must be compensated.
This is a monumental confirmation for content creators and publishers globally. Major AI players, Microsoft, Meta, Amazon, and leading startups like Perplexity and Mistral AI are now paying Wikipedia through its enterprise product to access its content for training their AI models.
This is a huge shift. I mean, historically, these tech giants just relied on freely scraping Wikipedia's 65 million articles. Why the sudden pivot to a compensated model?
The scale of the AI boom forced a change in the economic relationship. The free scraping by tech companies drastically increased server demand and operating costs for the nonprofit Wikimedia Foundation.
Right. They're a nonprofit.
They are. And since the foundation relies mainly on small public donations, absorbing those massive resource drains caused by corporate AI training was financially unsustainable and fundamentally unfair. They were providing essential global infrastructure without any compensation.
So the foundation leveraged its status as the world's most authoritative, trusted, and structured repository of general knowledge, and they turned it into an enterprise product.
Precisely. They spent significant time developing the Wikimedia Enterprise product. It's a structured, commercially viable platform offering specific features to handle the enormous scale and clean data needs of AI training. And this successful transition proves they can move these massive corporations from free, high-volume access to a structured, paid enterprise licensing model.
And this is the critical implication for investors, for publishers, and content creators. It confirms the data is being remonetized across the board. The initial gold rush of AI development, which was heavily funded by free, scraped data, is definitively over. Content creators, publishers, and platforms that own highly structured, trusted, or unique data are successfully transitioning to an enterprise licensing model.
And this raises the important question for you, the listener. Which other major data sources, particularly those currently struggling to monetize their extensive archives, think scientific journals, proprietary news databases, or specialized image libraries, which of them will follow suit now that Wikipedia has established this billion-dollar precedent? They will accelerate their enterprise strategies dramatically, knowing the largest AI companies are willing to pay billions to secure clean, authoritative training data and mitigate legal risk.
This has been a monumental day for AI strategy, spanning personalization, geopolitics, market disruption, and the establishment of new legal and economic frameworks.
Let's quickly synthesize the 4 core shifts we've unpacked, as these define the new competitive map for the next year. First, the personal moat established by Google. Utility driven by deep personal context now conclusively trumps general model capability. Second, hardware diversification. That $10 billion move towards specialized independence by OpenAI with Cerebras and the massive geopolitical fracturing demonstrated by Zhipu and Huawei.
Third, market research disruption. The confirmed accuracy and radical speed of the synthetic consumer methodology, which makes traditional, slow, and expensive focus groups economically unjustifiable. And finally, IP enforcement. Data and likeness are no longer free commodities, as demonstrated by McConaughey's federal trademark strategy and the successful monetization of Wikipedia's authoritative content.
And before we close, let's quickly address the 2 massive dramas that speak to the frantic talent and spending wars defining the current industry climate. We saw the drama at Thinking Machines Lab, where 2 co-founders returned to OpenAI, along with a 3rd key employee, after one co-founder was fired for unethical conduct and sharing confidential company information with competitors.
That whole volatile sequence, with the startup losing half its sounding team, while simultaneously trying to raise funds at a staggering $50 to $60 billion valuation. It just shows the intense scarcity and volatility of the AI talent market.
Founders and key engineers are being treated like star athletes, and loyalty is fragile, particularly when the difference between a successful IPO and a collapse rests on key individuals.
And speaking of scale, we have to note Microsoft's consumption commitment to Anthropic. It's staggering. The report indicates they are spending nearly $500 million annually on Anthropic models. This isn't just a venture investment, this is a consumption commitment, and it shows just how high the price tag is for securing access to top-tier frontier model capacity outside of a company's primary partner. It illustrates the frantic effort by every major player to ensure they have redundant access to the best models available.
A day of truly monumental foundational shifts across the entire stack. And this all leads to one final thought, one that builds on the IP and synthetic consumer segments. Given that AI models can now perfectly simulate human consumer behavior, and Matthew McConaughey is using federal law to protect his likeness, how long until we see the first major civil suit where a synthetic consumer is successfully used in court as evidence of specific market intent, say, to justify a pricing decision? Or conversely, where a synthetic voice or likeness is introduced as key evidence in a commercial dispute, completely bypassing the need for human testimony in certain contexts. The line between simulated reality and legal truth is about to be tested at the highest level.
A compelling and high-stakes thought to leave you with until our next deep dive. We'll talk to you soon.
That wraps up today's briefing. The signal for today is simulation. We are moving from simulating intelligence to simulating people. With the rise of synthetic consumers that can predict purchase behavior with 90% accuracy, companies can now A/B test products on thousands of AI agents before manufacturing a single unit. The feedback loop between idea and market just got infinitely faster and a lot cheaper. Before we go, a reminder for the leaders listening: are you drowning in dense legal text? JamgaMind is the new audio intelligence platform that turns 100-page healthcare or energy mandates into 5-minute executive briefings. Whether you are navigating Bill C-27, Canada, or the CMS 0057F interoperability rule, USA, our AI agents decode the liability so you don't have to. Start your specialized audio briefing today at jamgamind.com. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Please subscribe and share. Until Monday, keep unraveling the future.